All right, this is the law of sines, and this is based on something you learn in geometry, which is that when you have a triangle, each angle of the triangle has a special relationship to its opposite side. And one thing I want you to notice here, when we're doing trigonometry with triangles, a common way to label the triangles is with A, B, and C, both lowercase and capital. So what I want you to notice about this diagram is that we have angle A with a capital letter for the angle. And then if you go across the triangle to the opposite side, that's labeled with a lowercase a. You have angle B with the capital B. You go across, you have a lowercase b. Angle C with a capital C, the opposite side is labeled with a lowercase c. So you use capital letters for angles, lowercase letters for sides, and the letter of each angle corresponds to the letter of the opposite side. And so what we end up with is this proportion. So law of sine says if you take the sine of an angle and make a ratio or a fraction of that with the measure of its opposite side, that will be proportional to all the sines of the other angles divided by their opposite sides. So sine of angle A over A is equal to sine of angle B over B is equal to sine of angle C over C. So we're going to do some examples here where you can see how to use this to solve for missing sides and angles. So here's the first example. It says solve for x. Using the law of sines, we got to round to the nearest whole number, so we'll expect to get some kind of decimal out of this. So what we want to do is match up the angles and their opposite sides. So 45 or 46.5, that matches up with the x. And 39.4 matches up with the 7. So the way we would set this up is we would say a sine of 46.5 over x, we match it up with its opposite side and make a fraction, is equal to the sine of 39.4 over 7, the measure of its opposite side. And so this is a proportion. We'll solve it by cross multiplying. So I'll take the 7 and multiply it by sine of 46.5. I'll take the x and multiply it by sine of 39.4. And then to solve for x, I need to divide by sine of 39.4. And it's very important you divide by that whole thing, sine of 39.4. Don't just divide by 39.4. Divide by the whole thing. All right, so those cancel out. So I've just cross multiplied just like you would cross multiply like in middle school to solve a similar triangle problem or something like that. But now obviously I've got something that's a lot more complicated and I need a decent calculator to work this out. I'm going to use the Google calculator because that's what I've got handy and that's what everybody has available. So you are free to use other scientific calculators for this. But what I had was 7 times sine of 46.5 divided by sine of 39.4. Now, before I hit enter and work this out, I need to make sure I'm dealing in the right thing. So my angles are measured in degrees. I don't have like radians in this problem. And we're mainly dealing with degrees in this lesson. So right here, there's this button on the Google calculator, and you'll see radians is in black, degrees is in gray. I want to hit that button, and now it put degrees in black and radians in gray. So now this is set in degrees because that's what I want to use. So now I'm just going to hit equal, and I get 7.9996. So we are rounding to the nearest whole number. So when we do that, we are going to get x equals 8 because it was 7.9996. 0.99, whatever. Now that seems pretty reasonable. You always want to make sure your answer is reasonable. If the left side of this triangle is 7, it makes sense that the right side is 8. And you also know one thing you learn in geometry is longer sides are across from larger angles. So we would expect the side that's across from 46.5 to be a little bit bigger than the side that's across from 39.4. All right, next one. Here we have a missing angle. We have a theta as our variable. It's going to work the same way. We're going to take this theta, find its opposite side. So we're going to say sine of theta, our missing angle, over 3.6 is equal to sine of the other angle here, 100, over 5.1. And we're going to cross multiply. And the easiest way to do this, the thing we're trying to solve for theta, and we can't quite get theta by itself because it's inside that sine. But what we can do is get sine of theta by itself. And that's going to be pretty easy to do just by multiplying by 3.6. So I'm going to take the 3.6 and cross multiply it. That gives me sine of theta is equal to 3.6 times sine of 100 over 5.1. And so I'm going to have to bounce back to the old Google calculator. We're going to have to go back and forth a couple times here. So 3.6 sine of 100 over 5.1. So 3.6 sine of 100 divided by 5.1. We are set in degrees, so we're good there. That is equal to 0.695, etc. I'm going to save that answer. That's up here as my answer. So now what I need to do here, I'm going to round that off to 0.695. So we have sine of theta equals 0.695. So that's great. We know what sine of theta is, but we actually want to know what the angle itself is. We want to know what theta is. What's our missing angle? So to do that, we use inverse sine, which is that tool we have that says, okay, if I want to find the angle, knowing what its sine is, I can say inverse sine, sine with a little -1 of 0.695 is equal to theta. It kind of switches the place of the sine and the angle. And so now I'm going to go back to the Google calculator. I'm going to take the inverse sine of that number I just found, and that should give me my angle. There's probably a more efficient way to do this, but to do inverse sine on the Google calculator, you see this button up here that says inv, INV. Click on that, and what that does is it opens up all your inverse trig functions here. So I'm going to click the inverse sine with a little -1. And remember, another way of saying that, when we first learned this, we learned another way to say that is as arc sine, which is what it types there. And then I want to find the inverse sine of the answer I just got. So I'm going to click the answer button, and it's gonna put an A and S for answer. But I can see, I don't know how well you can see this on the video, but right at the top of the little calculator window, it says my answer, A and S equals, and it gives me that number, that 0.695 that we just got by working that problem out. So I'm going to take the arc sine, the inverse sine of that number, and that should give me the measure of my angle. And so it gives me 44.03, etc. This one, it rounded off to the nearest degree, so it's going to be 44 degrees. So I'm going to go back to my problem here. And so my angle here is 44 degrees. And again, make sure your answer is reasonable. This totally looks like it could be a 44-degree angle. That totally makes sense in the context of this problem. If you got like a 0.2-degree angle or something like that, you probably did something wrong. So Next example. This is a fun one, and we're going to see what happens here. We also have an angle that we're looking for. So we're going to have to deal with that inverse sine thing again. Maybe. Let's go ahead and set it up. So theta here goes with the 16. So we say sine of theta over the 16 equals sine of the other angle, which is 30, over its opposite side, which is 7. And again, if we're trying to get theta by itself, or solve for theta, we just need to get rid of the 16. So I'll cross multiply the 16. We have sine of theta equals 16 sine of 30 over 7. So 16 sine of 30 over 7. And again, I'm going to slip over to the Google calculator. 16 sine of 30 divided by 7. And when I work this out, look at what I get. I get 1.142, etc. So let me go back over here and we'll talk about what this means. If I get 1.14 for sine of theta, I've got a problem. One thing we know about the sine of any angle, no matter how big, no matter how small, no matter whether it's positive or negative, the sine of any angle is always going to be a number that's greater than or equal to -1 and less than or equal to +1. If I get a number that's bigger than +1 or less than -1, I have a problem because there is no angle that would actually ever give me that sign. So when you're doing a law of sine problems and you get a number that's bigger than 1, then what you have is that this triangle, a triangle with a side of 16 and a side of 7 and a 30-degree angle, is impossible. So this is a triangle that is not possible. You could not actually make a triangle with these measurements. And if you actually were to measure these sides, you will see that the 16 and the 7 cannot actually be right. So this triangle is an impossible triangle. And you get that if the sine of theta has an absolute value greater than 1. Because your sines are always between -1 and +1. So that's a fun thing to come across occasionally. So that's your impossible triangle. All right, Leaning Tower of Pisa. This is a word problem. I think that the hardest thing about a word problem, that the problems themselves aren't really that different from any of the other problems. It's just reading them carefully and knowing what they're talking about. Let me get a color that's going to show up well on this picture. I think that'll show up okay. So this tower, Leaning Tower of Pisa, leans 5.6 degrees from the vertical. So if you can see what I've drawn here already, the pink line is a vertical line, vertical straight up from the ground. And what it's saying is from that imaginary vertical line, if you take the actual side of the tower, it makes a 5.6 degree angle. So the reason that's important is because if we want to find this angle, we can take 90 degrees because a perfect vertical would be a 90-degree angle. We can subtract 5.6 and we will find this is an 84.4 degree angle that the tower makes with the ground. Since it leans in 5.6 degrees, it makes an 84.4 degree angle instead of, say, a 90-degree angle, which you would normally hope a building would make. It says a tourist stands 105 meters from the base of the tower. So this yellow line I drew here, that's going to be the 105. That may be hard to see, but that's 105 meters along the base. And then it says she measures the angle of elevation to the top of the tower. So the idea is she's standing way out here. She's looking up to the top of the tower. That's terrible. At an angle, so this angle right here, this is your angle of elevation from the ground where she's standing up to the top of the tower, angle of 29.2. So when it says angle of elevation, that's what it's talking about. And it wants us to find the length of the tower. So the length of the tower is going to be the height. The reason they don't say height is because technically height is always measured on a perpendicular. It's always at a 90-degree angle straight up. It wants this yellow line here that tells us the actual length of the tower on its lean from the bottom all the way up to the top. And so that's going to be our x. Okay, so here's the issue we have if we try to set this up. The 29.2 and the x go together. That's great. So I have sine of 29.2 over x. That works. The x is opposite across from the 29.2. The 84.4 and the 105, however, do not go together. So sometimes what you need to do is just use some basic geometry. We know that the angles of a triangle add up to 180. So what we can do is we can add together 84.4 and 29.2. Get 113.6. We can subtract that from 180. And we can figure out what that missing side is. So we end up with 66.4 degrees. Not the missing side, I'm sorry, the missing angle. The missing angle. Up here at the top is going to be 66.4 degrees. The reason that's important is because 66.4 degrees is opposite the bottom of the triangle, the length from the tourist to the base of the tower, which is 105, which is a measurement we actually know. We've got to use the stuff we know to be able to figure this out. So sine of 66.4 over 105. So there we go. Now we can cross multiply. So we take 105 times sine of 29.2. Equals x times sine of 66.4. And we're going to divide both sides by the sine of 66.4 to get x by itself. So one more time to the old Google calculator to work this out. Okay, we've got 105 times the sine of 29.2 divided. Let me try that one more time. There we go. Divided by the sine of 66.4. And we get 55.9. And so let's go back over here. So our answer for x is 55.9. That is in meters. So the height of the length of the Leaning Tower of Pisa measured along the diagonal here is 55.9 meters, which is about like 170 some feet. So that's a pretty reasonable measurement, and it's actually accurate. So there you go. That's how you set up and work out problems using the law of sines.